Okay, so the first thing is how to log in to the computer. I want to use Logger Pro on these computers, but sometimes I need to be able to log in and have override control for Java. So instead of using your Active Directory sign-in on the computers in 111, when you pull up the sign-in screen up here in the upper right, there's a thing that says sign in with local user. So you're going to click on that. Then you're going to type in the class number. So CCCS111 is the classroom number, and it should be all caps. Then the password, the super secret password is physics with a capital P. Okay. And that will log you in as a local user on this computer. And that's going to matter if we have to use Java for a lab, because these computers get cranky about using Java. And if you sign in this way, you have local control. Okay, now, so that's the first part that we need to worry about. So it's going to do its little thing here. We'll let it do its thing. Now, the next part is the lab itself. Let me move some stuff out of the way here. Okay, so when you come in, you're going to find the following things. Okay, you're going to have a blue resonance tube set up. The resonance tube, if you look at it, is got a cap, a removable cap on one end. Okay, you need to make sure that it's on the end so that when you pull out the tube, there's a ruler on here. Okay, when you pull out the tube, the ruler has two scales on it. It says closed and open. That should be on the end where the cap is not. So don't put the cap on this end of the tube, put it on the other end. Okay, all right. So that should already be set up correctly, but if something unfortunate occurs and you need to change things around, now you'll know. Okay. So the next thing that you'll have is a frequency generator. Okay. So let me see if I can move this camera without giving us all motion sickness. Here we go. Not very well, but anyway. So the next thing you have is a frequency generator, okay? This frequency generator has a power supply and has an on-off switch right up here. The power supply plugs into the top. The on-off switch is right here. When you turn it on, it defaults to 100 hertz, okay? To change it, the coarse adjustment is to the far left. The fine adjustment, which does the decimal places, is the middle button. And then the sound adjustment or the loudness adjustment is right here. Okay, so we'll turn that back off for now, and I'm going to put the camera back up so you can watch me set everything else up. Okay, sorry about that. Hopefully everybody didn't get motion sickness when we move that. All right, so now the next thing is we need to be able to hear something. We need to be able to hear the sound. So in this box, we have a speaker. Now, remember I said you need to make note of the make and model numbers of everything. Those are all published right here. So you can either write this down or you can take a photograph of this. I don't care. All right. So, but you need to know that this is a Pasco Scientific open speaker model number WA9900. Okay. So you need to make note of that. So the speaker attaches to the generator, the sound generator. Here's your speaker. Now, oops. So, the trick with the speaker is it needs to make about a 45-degree angle with the opening, okay? It doesn't need to be like this, okay? It needs to make about a 45-degree angle with the opening so that you're not getting too much reverberation from the speaker. Okay, the way we power the speaker is you've got these cables here that plug into the signal generator and then plug into the speaker. Okay, so like so, up top, and then to the speaker. And I'm not particularly particular about, oh, red's got to go to red and black's got to go to black, because either way, it doesn't matter here, okay? So there's that. Power supply is plugged in, and this will power the speaker. You don't have to have a separate power supply. So I'm going to turn this up. You want to do 2 frequencies in this lab. All right, I suggest doing 350 hertz and 450 hertz. So I'm going to start with 350. So I'm going to dial this to 350. So you see now my dial here reads 350. And then I'm going to turn it up. Now, it doesn't have to be very loud. Okay? Now, part of this lab is you can just listen with your own ears and try to figure out what you're hearing. So the whole point of this is you're going to create a standing wave in this tube. All right? This tube is a closed open system. So it's an asymmetric boundary condition. So the cap is going to create a node. The open end is going to create an antinode. And basically what I'm trying to do is I'm trying to match up the air column in this tube to the length of the wavelength of this 350 hertz sound. Okay? So right now the tube is completely closed. So there is no air column vibrating. All right? So I need to increase the air column. So the way that I do that is I come down here and I pull out on the tube. And that's why I said it was important to make sure the cap was at the correct end, because you want to use this ruler on here as the length of your air tube. So you want to use for this one the closed tube ruler. Okay, so I'm going to pull this out. And what I'm going to do, see how that got quieter a little bit and even quieter? I'm not changing the loudness of the sound. What's happening is I am creating a situation here of destructive interference. But now I'm looking for one of constructive interference. So I'm going to keep moving this. Until it sounds the loudest. It's going to make the loudest sound. Okay, so part of that's up to your ear to decide where that's the loudest. Now, I'm giving you a backup. Okay, I'm giving you a backup. So you can kind of hear it when I push it closed and then pull it back open. You can hear it get louder and softer. But I'm going to try to decide where it's the loudest. Now, part of it even is I can feel the tube vibrating in my fingers. But then as I pass that loud spot, it gets quieter again. Okay? And then somewhere out here, there'll be another one. Okay, so I'm going to listen for those loud sounds and I'm going to record those positions. Now, if I'm not sure if that's where the loudest sound is, I'm giving you a backup plan. And your backup plan is this microphone. Okay, this microphone is going to be attached to the stand so that you can use it to double check what you think you're hearing. Okay, so I can put the microphone in here. And you've got some different clamps that you can use to hold it. I usually use one of these finger clamps to hold it. And you can use Longer Pro as your ears instead of your actual ears. Okay, but that's kind of up to you which one you would prefer to use. Because sometimes it's hard for me to distinguish when it's the loudest. I can tell it's getting louder, but I can't tell exactly when it's the loudest it's going to be. So I can put the microphone in there and it can listen for me. So What you're going to do is you're going to listen for 3 places where that sound gets loud, okay? And those are going to correspond to standing wave patterns in this tube, okay? So you're going to do that for 350 hertz, then you're going to start all over, close the tube, and do it again for 450 hertz, okay? So you'll just adjust this up to 450 and do the same process. Then you're going to create a symmetric standing waveform, and the way you do that is you take the tube out, or take the cap out, okay? You take the cap out. Now you're going to listen for a new standing waveform, but the problem with doing this one is with the closed tube, I know that I started with no air in there whatsoever. So I know there were no standing waveforms yet in the tube. So the first one I heard was the fundamental, okay? It was the lowest frequency standing waveform that thing, or the lowest wavelength standing waveform that thing could produce, or the lowest harmonic. But when I take the cap out, I don't know, because now this whole air column is allowed to vibrate, so I don't know what's hiding inside here. All I know is I need to listen for a loud sound, so let me try to see if I can find one. Now you're going to read the open scale down here, because that takes into account what's already here, plus the additional length of air you made by pulling this tube out. Sounds like I almost started at one. Right in there. Okay, so I'm going to move out. So I would record that length, and I'm going to keep going. It's starting to get louder again. So now, all I know is between the first one that I heard and the second one that I heard is one standing waveform, one standing wave pattern. I don't know how many are already in here, so I don't know if I'm listening to the first harmonic, the third harmonic, the fourth harmonic, whatever. All I know is I went from one to the next. So the distance between the first loud sound and the second loud sound is going to tell me about the wavelength. I don't know what's in here already. So for the open tube, it's not as simple as, oh, that's the fundamental frequency. I don't know that. Does that make sense to everybody? I hope. All right. So you're going to try to listen for 3 loud sounds again, but it's only going to give you 2 wavelengths that you can use instead of 3 with the closed end. You're going to do open, open for 350 and 450. So you're going to have 4 trials here. Okay, you're going to have 4 trials on this. Now, if you want to use the microphone as a backup ear, we're going to go to the computer. So when you log in with a local user, it's going to show you this gibber. Just cancel out of that and cancel out of that. We don't care about that. And it's going to eventually do its thing here. Now, you need to make sure that you're plugged into the Lab Pro handset thing here and that it's turned on. Okay, so it should be plugged in when you get here, and then you can turn it on and it'll sing a little song to you and tell you if it's on or not. Okay, then you want to use Logger Pro. So the quickest way to find Logger Pro is just to use your Finder app, Finder tool here, if it'll work. And usually it's under applications. Now, these have not, doesn't look like these have been re-imaged, so there's a whole bunch of other stuff on here. So if it had been a fairly new semester, we would be able to find it pretty easy. But go under applications, okay? And then you should go down here to Logger Pro. Click on that. And then the Logger Pro you choose is the one that's got the little folder with a little caliper by it. So you just click on Logger Pro. And the little thing will bounce down here telling you it's doing its thing. And eventually it will open up Logger Pro. Now, if you remember how Logger Pro works, it should default to the correct setting for the sensor that you're using. Okay? And in this case, we're using the microphone. All right, if it doesn't default to that, then make sure that your thing is powered on, okay? Make sure it's all plugged in here. So make sure everything is powered on, and then what I do, if it can't find it, is I go, and if it does, and it pops up with this business about Active Directory, just cancel out of that. We don't care. Okay, it's going to try to make you log in with Active Directory, and we don't want to. Okay, so if it doesn't find your sensor, the way that you can find that is you can go up to, where is he at? Tell it to find it. You can go up, it should go under Setup Sensors or Connect Interface with our Lab Pro. And then it will find it eventually. This one may not be want to talk to it this morning. So you can go underneath there and it will, oh, it's mad. Why are you mad? Also, if you get one that doesn't work, which does happen, back in the back of the room, there's a box here with a whole bunch of them on it. And this is one that's going to get legit. So I'll go get another one. All right. Turn that down until we're ready for it. All right. So if you get one that doesn't act like it wants to work, just go get yourself another one. But do me a favor and don't put the broke one back in there. Okay. Leave it up on the front desk and send me an email and said, hey, this doesn't work, so I can have Mr. Allen fix it. See, it should have a happy song like that, so that should mean it's working. Okay. All right, so there. Now we've got, if you look on the screen, now we've got sound pressure here as our unit, and then that tells me it's found the microphone. Now, what you want to do for this is under your data collection, what you're going to do is you're going to choose continuous data collection, and if it gripes, then just lower the sample rate to 250 because it gets mad if you do that, if it defaults. So you're just going to do a continuous data collection, and I'll show you why. Okay, so right now, I've got it set up on continuous data collection. I've got sound pressure here. So what this is going to do, and let me move this out. What this is going to do is it's basically going to record the amplitude of the sound. And what will happen is when the sound gets louder, the graph will get larger, it'll get wider, and then as it gets quieter, it'll narrow down. So you can kind of hone in on where you think the loudest sound is. So let me see if we can get it to do that for you guys. Get all set here, turn this up a little. And I'm going to hit go on my data collection. So there it goes. Now, I'm going to start to move the tube. Okay, so see how it's getting wider right here? That tells you that the sound is getting louder. Now it's picking up me talking too. That tells you that the sound is getting louder. And then if I move past that resonant point, see how it's getting narrower? That tells you that the sound is getting quieter, okay? So what you need to do then is you need to use your screen and you need to kind of hone in on where this sound is the loudest. Now I could turn up the sample rate some, and this would, all this jumping around is me talking, but I could turn up the sample rate some where this will be a little bit smoother, but basically I want to find at what length of tube I have down here that gives me the loudest sound, okay? So I want to find where that graph gets the widest. So you're going to have to kind of move back and forth and dial in on where that sound is the loudest. And that's what you want to record as your length, okay? Now that is not your wavelength, all right? That is a length that then you can convert to wavelength when you think about how much of the standing waveform is inside this tube, all right? So that's how you use your microphone. When you're done with that run, you just hit stop, and you don't want to, let's see, you want to erase, and I'm going to erase and continue. When you get ready to do it again, you just erase and continue, and it'll do the next run, okay? You don't need to save, you're just using this as a visual tool. You're not recording any of the numbers on it, okay? All right, so turn that off because that gets annoying after a little bit. So what you're going to do is you're going to collect data with this tube. You're going to do 350 hertz, open, open, and closed open, so with the cap and without, and 450 hertz, open, open, and closed open, so with and without the cap. Now, you also need to record the air temperature in the room while you're doing this, so you'll find a thermometer at your station. All right, now these thermometers are sneaky because they've got both Fahrenheit and Celsius on them. You don't want to use Fahrenheit, I'll just tell you that. So you need to record the air temperature because you're going to need that also for the lab, okay? All right, so you have a thermometer at your station as well. So when you come in, you should have everything set up like it should be. You will just have to log into the computer, okay, and start Logger Pro. But everything should be here for you. You may have to turn on this, okay? You'll have to turn this on, but everything should be set up just like this for you when you get here, okay? All right, now, turn y'all around. Yes, you're doing 4 things. So closed and open for each one. Yes. Okay. All right. So the reason you're doing this is because when you look at this system, all right, first thing, there is a way to calculate. I'm going to raise the screen so it's not in the corner here. Okay. So the reason we're doing this is because we want to determine the speed of sound in air. So we're going to have a theoretical value of speed of sound that we're going to use the equation for the speed of sound in dry air. That's why you need the temperature. So our theoretical speed is going to be that formula that's in the notes, but also should be in the reading. It says, if I know the temperature in Celsius, I can take 331 plus 0.6 times the temperature in Celsius, and that gives me the speed of sound in meters per second. So that's why you need the thermometer. Okay, that's why you need the thermometer, is to record that temperature so you can find the speed of sound. So let's just play like it's 20 degrees Celsius in this room. So I would take 20 degrees Celsius and I would put it here, so I would get the V theoretical is 331 plus 0.6 times 20, which is 12. So if I add those together, I get 343 meters per second. That's going to be my theoretical speed that I'm going to test against my experimental speeds. Okay. Now, so I'll make a note of that somewhere in my book or in my handout. Okay, now, how am I going to get my experimental speeds? Well, you're basically doing 4 trials, okay? So for a closed tube, what happens is, for a closed tube, as I move this back, I start with no air in the column, and as I move that cap back, what I'm trying to do is fit in a standing waveform that's asymmetric. It has a node at one end and an antinode at the other. Okay? So I'm always going to have a node at the cap, and I'm always going to have an antinode at the opening. Okay? Now, let's say that my first cap position was right here, where I hear my first loud sound. So this distance right here, you can call that Y1. Okay, that's your first loud sound. So this was the first position where I hear the first resonance. So that's resonance is a fancy word for the first loud sound. Okay, now what that means is then I have put in the first waveform that I can fit that has a node at one end and an antinode at the other. And the simplest form that I can do that with is one that looks like this, where I have basically this shape. Okay? I call standing waveform shapes footballs because they look like footballs if you look at them in the book. So we got half of a football, basically there. Okay, we've got half of a football. So what I need to figure out is, what I've done is I have taken the waveform and I have matched the size of the air column to a preset wavelength. I set the wavelength when I picked out what frequency that I had. Okay, so I'm matching my air column so that that lines up in there. So what you're hearing when I get that loud sound is I'm basically pulling this football shape back into there such that the widest part of the form is at that opening, and that's what you hear when you hear that loud sound. You hear that resonance. Okay? So I need to figure out how this Y1 that I've measured is related to the wavelength. Well, what's the definition of wavelength? Anybody remember? Have you read that part yet? Anybody remember? It's the distance for one complete oscillation of the waveform, right? So a complete oscillation would look like a whole football, right? To trace out a whole waveform. Does that make sense? So if I want to trace out a whole football, how many distances of Y1 would I have to travel? Right? Well, I got to get the top part of the football, so there's 1. And then I'm going to get that part, so that's 2, 3, 4. Because this is symmetric. So to trace out a whole football, I would need this length right here 4 times. Right? Yeah? So Y1 corresponds to 1/4 of the wavelength of my wave. Okay? Now, where am I going to hear my next loud sound? Okay? So I'm going to erase this part right here. Where am I going to hear my next loud sound? Well, I've got to have a node at one end and an antinode at the other end. So my next loud sound is going to look like this, where I've got a whole football plus half. So now, if I measure the distance from this first loud sound to the next loud sound, and I call that Y2, okay, so I'm measuring this distance right here, not from the end of the tube, but from the first resonance to the next one. Now I've got a whole football in there. That's my next loud sound. Okay, it's still asymmetric. I still have a node and an antinode. All right. So now I've got this Y2. So if I want to trace out a whole football there, I travel one length of Y2 to get the top part and one length of Y2 to get the bottom part. So Y2 is equal to 1/2 of the wavelength. Y'all see that? Then, if I kept moving this cap on out, eventually I would get another waveform, and what would it look like? It would look like 2.5 footballs. So I would move this out, and I would get a third loud sound when I matched up another node and an antinode, and I would have another football shape sitting here. So it would look, I'll just draw it, if I can draw it real quick, it would look something like this. Well, not like that, that's terrible. Let me try that again. Okay, let me try that again. So it would look like this. Something like that, okay? Which yours is gonna be better because you're gonna draw it better than I did. But it's gonna basically be this distance right here again added onto the tube, isn't it? Because I'm just adding another football and these are all symmetric, okay? So that would give you a Y3. So you would measure from here to the next loud sound, and that would be Y3. So that would give you 1/2 of the wavelength again. So that's your 3 trials, okay? That's your 3 measurements that you're going to take of your wavelength, okay? So now you're going to do that for 350, then you're going to go again and do it for 450, okay? Now you kind of know how to check this though, right? Because if I measure Y1 and it's half of a football, then this length right here ought to be double of Y1, or roughly double. So like, let's say I measure Y1 to be 20. Then I don't even need to bother listening for another loud sound until I get to about 60, because I'm going to add on 40 to that. So I'd start listening at like 55 or something like that, and so on. Okay, so you kind of know. So there's your 3 values. You're going to find 3 numbers. You're going to find a wavelength. With each one, you're going to average it. Okay, so you're going to have lambda 1, lambda 2, lambda 3 for your 3 trials, and you're going to average it. Then that's what you're going to use in the wave speed equation. V is equal to F lambda to calculate the wave speed, because you know the frequency because you set it at 350 or 450. Now you've got your wavelength. So you're going to have 4 different calculations of wave speed, all right, that you'll compare to this theoretical value. You'll have one for 350 closed, 350 open, 450 closed, 450 open. They ought to all be about the same, right? They should all be about the same number, because the speed of sound is the speed of sound, right? If different frequencies traveled at different speeds, that would fundamentally mess up how we listen to music, okay? The temperature in Celsius you're going to get from your thermometer, right? So it's going to be different on different days depending on what the HVAC system does in this building, okay? So that's why you've got a thermometer at each station. Okay, now let's imagine now we're going to talk about when we take the cap off, what will it look like? So now I've still got the same tube, but now I'm going to take the cap off. Okay, so now what I've got is a symmetric boundary condition with antinodes at either end. Okay, So all I know is I've got an antinode at either end. So I'm going to say the first simplest waveform that I could form inside here, and I don't know what length that is, would just be a whole football, but it's going to look funny because the antinodes are at either end. So it's like I cut my football in half and flipped it backwards on itself. I don't know in my tube how many I started with. So all I know is I've got an antinode at either end. Okay, and then when I pull it out, I fit in one more whole football because that's the only way I can get a symmetric boundary condition. So there, my Y1, my distance between Y2 and Y1 is going to be equal to 1/2 the wavelength because I have to slide it out enough that I can fit another whole football in there. And then the same thing with the distance between Y3 and Y2. That's going to be 1/2 of wavelength. So you're only going to have 2 values of wavelength there, okay? You might be able to pull it out enough to get a third one, but I don't think so. I think that for these frequencies, you can only get 2. So then you're going to do the same thing again. You're going to calculate your average wavelength. You're going to use that in your wave speed equation, and then you're going to calculate the speed of sound, all right? Now, what I want you to pay attention to when you're doing this lab, all right, is I want you to pay attention to where all the places that you could be off in measuring this length are. Because that's going to matter when you write the lab report. There is no such thing as human error, okay? Human error is a big, sloppy word that is not really an official type of error. There's parallax error, there's measurement error, there's perception error. So that's why I said with the microphone, you can slide it in and out and listen where it's the loudest. See how much you can move that thing in and out and it doesn't change the width of that waveform. You need to note that. Also, is the ruler, you know, is it perfectly on the end? What is the spacing of the units? Are you halfway between a mark or a third of the way between the mark? You can't really tell. So I want you to think about all the places where you could mess up in measuring the length. Like, was your tube sort of sagging down and when I wrote the number down, could I have moved it up and held it up straighter and got a better number? Okay, so pay attention to those things because those are going to contribute to your sources of error. Okay. All right. I'm trying to think what else. So I've told you to make sure you record the make and models. On your measuring tools, make sure you record the smallest unit. So is it millimeters? Is it centimeters? On this frequency generator, is it 0.1 hertz? Is it 0.01 hertz? Make sure you record the smallest unit because that's going to matter when we start talking about precision of instruments. Okay? All right. Okay, so anybody got any questions? That you can unmute yourself and ask your questions if you want to. Or you just kind of got to do the lab and see what happens. So this lab will be available from today, okay, and then until noon Friday, and then it goes away forever, okay? So yeah, the login for the computer is CCCS111, the room number, not the CRN number, the room number, and then capital P physics is the password. Okay, this I'm gonna try to put this up on YouTube so you can refer back to it. I'll put it on the blackboard and link it through my YouTube channel so you can refer back to it. Okay, all right, I'm gonna stop the recording and then see if we have just a few minutes and see if you guys just have any admin question about the class.